Okay, so today we're going to be talking about procedural generation. The article itself is called Generating Optimized 2D Art in Unity, Procedural Generation for Stylized and Optimized 2D Foliage. That's like a lot of words just to say 2D art generation within Unity. So procedural generation is a pretty huge topic. Today we're only going to be talking about 2D generation because that's all my brain figured out today. But it's actually kind of cool and it's not incredibly hard. It's probably harder to implement, but the theory behind it is more we're going to be talking about today. So with procedural generation, the most common way to generate 2D art, at least, or he says the most common way is something called L systems or Linden-Meyer systems. Linden-Meyer systems are commonly used for foliage generation, which is trees, plants, all that fun shit. And it's pretty easy, and I'm gonna give you a brief overview, and then I'm gonna show like an example real quick. So L systems are basically a collection of symbols and rules that can be translated into geometrical render instructions. That geometrical render instructions basically just means how we're making the thing on screen. And sometimes that's done pre-gameplay, because obviously you can make an asset out of Engine and then move it in, but that wouldn't be necessarily considered geometrical rendering, at least the way I'm thinking about it. I don't think it's an actual term. I just said it because it sounded smart. Anyways, so as a basic overview of symbols and rules within a Linden-Meyer system, the symbols we're going to be using are just the alphabet, A, B, C, D, all that fun jazz, right? Rules are things we use when we're iterating through our sentence to make sure that, to compare and then use to change the sentence, right? So I drew a little thing. Okay, so we have A and B right here, right? This is something called an axiom. This is what we start with at the start of generation, right? So with AB, on our first iteration, we're just starting here. Then when we begin to iterate, we check A and then we check B. When we're checking A and B, we're checking them against our rules. Up here, you can see A is equal to AB and B is equal to BA. While we're iterating, we're going to check all symbols within the sentence. So we're going to check A and then we're going to check B. And then if there's a corresponding rule to them, we're going to replace that symbol with the new symbols. So now A got swapped out for AB and B got swapped out for BA. Each of those instructions could mean something within code. If you were manipulating like a point or something, you could go like A means forward, B means left. And then whenever you get to B, you would do B code where it's move whatever to the left and then A to go forward. And that's how you would translate that into like actual rendering. But yeah, that's a basic overview of L systems. I had to read a separate article because he didn't explain shit about it. But this can get like really insane. So you can do something called barnacling, which is where you surround large objects with few smaller objects, not like small like bushes or whatever, or even smaller objects like weeds or whatever. That's definitely something you could do using Linden-Meyer systems. But as for how, he does a lot of stuff where he's talking about things to add more visual variety to procedural generation. But we aren't terribly concerned with that. I did take notes on it, but it's whatever. He next talks about data structures, or more specifically, what we're going to be discussing is setting up trees that can be genetically mutated. So with genetic mutation, we're not talking about like actually changing DNA. What we're talking about is changing how code works. Specifically, our Linden-Meyer or L system code to then generate a tree differently. So if we take rules from one system or one tree and rules from another tree, and then begin iterating with a combination of both of those rules, you're going to get an entirely new tree that is going to exist as a combination of both of those. That would be like how you would genetically mutate using an L system. Specifically, he mentioned something called a genetic algorithm, which is what he said you should use for this. I'm not entirely sure what it is. What I found as an explanation was that it's a mathematical formula that uses selection rules, crossover rules, and mutation rules to create a child when given two parents, which is essentially like all genetic stuff. The rules themselves would sort of be like what we were talking about earlier, except I don't think it would determine or do it based off the sentence. Oh no, it would have to. Yeah, so it would be based off each parent sentence. So if I take one tree I generated and another tree I generated, I would look at those sentences and probably make a new one and then also new rules. Yeah. And then as finishing out to this, he talks about good tool design. Making tools is part of a technical designer's job generally. So I just thought these were interesting. A single struct for plant DNA. Plant DNA is just what symbols, how symbols affect rendering. So like if I want A to be forward or I want A to be left, I should expose that parameter in the editor so then anybody can change it. And a struct is just a collection of different kinds of variables. It's sort of like, imagine you have a bucket, but you throw everything in that bucket. So you have food in there, you have toys, you have cans, you have wrappers, you have a bunch of random shit in there, but it's still contained within the bucket. Usually you'd want a struct to be more uniform and not just random shit, because if you can make shit with stuff in that bucket, that's good. But yeah, each parameter has fixed constraints, so that means A is only going to go so much forward, B is only going to ever turn so much left, and you can change that parameter, and changing that parameter will change how your trees generate, even if you give it the same DNA and symbols. And UI for other functions is something he mentioned. So mutation is what we talked about earlier. You should be able to select two trees and just press a button to get a new tree. That should be how it works, ideally. How the fuck you do that? No idea. Honestly, I'm gonna start working in Unity at some point this month, hopefully, and we'll see if I'm able to figure this out. I asked him for resources and stuff, so hopefully. But yeah, that's June 3rd. We learned stuff today.